So if you're staring down this massive, totally intimidating operating system syllabus and wondering how on earth you're going to survive the final, just take a deep breath. Today we're taking a mountain of historical exam data and turning it into a hyper-targeted battle plan. We actually analyzed 7 past papers, that's 980 cumulative marks, to map out exactly what you need to study, and honestly, what you can just totally ignore. The goal here is simple. Take you from overwhelmed to an absolute expert who can systematically lock down 55+ marks on a 70-mark paper. Let's get into it.
Here's our exact roadmap for today. We'll start with cracking the exam itself, then dive into concurrency and deadlock strategies, memory management and paging, disk scheduling, mastering system software, and finally, your step-by-step 55+ scoring playbook.
All right, part 1, cracking the 70-mark exam and the hidden math behind it.
You know, the biggest mistake students make is trying to read the entire textbook from cover to cover. No way. Acing this test is really about hacking the format. Based on all that historical data, it turns out that 54% of the paper is just medium toughness questions. Only 26% is hard, and 20% is easy. Think about that for a second. If you just master the predictable medium questions and those easy definitions, you're literally passing before you even touch the hardest numericals. It's a huge tactical advantage.
Let's move to part 2. While the early units build your foundation, the real scoring begins with concurrency and deadlock strategies in high-yield Unit 3. We're going to start by picking off the rapid-fire definition questions. Historically, comparing mutex and semaphore has shown up 6 times. That's 50 marks across past papers. You absolutely have to know this. Mutex is basically a simple binary lock. It's an ownership concept that completely stops simultaneous access to a shared resource. A semaphore, though, is an integer variable that uses weight and signal operations, and it can actually be a counting semaphore, not just binary. Lock those 2 definitions in your brain for some seriously quick, easy points.
Now, what's really fascinating here is that 4 simple bullet points actually unlock the medium toughness deadlock questions that show up constantly. For a deadlock to happen, all 4 of these conditions have to be present at the exact same time. First, mutual exclusion, meaning resources cannot be shared. Second, holding weight, which is where a process holds a resource while waiting for another one. Third, no preemption, meaning resources can't just be forcibly taken away. And finally, circular wait, literally a closed chain of waiting processes. Memorize these 4 and you've just secured yourself another easy 8 to 10 marks.
And you know, the banker's algorithm is a perfect example of how intimidating an exam can look versus how simple it actually is. When you get a real banker's algorithm question, it usually looks like a terrifying wall of numbers, right? But the secret? The very first step to solving this supposedly hard category question is literally just elementary school subtraction. To calculate the need matrix, which is basically always the first thing they ask, you just subtract the allocation matrix from the max matrix. That is literally it. So don't let the formatting scare you off.
Moving right along to part 3, memory management and paging. It's time to conquer Unit 4.
So Unit 4 is where those theoretical concepts translate directly into heavy, super predictable numerical points. But just like before, we start with the easy definition marks. The entire core concept of memory management really comes down to understanding the difference between a logical and a physical address. A logical address is generated by the CPU. It's virtual. It doesn't physically exist in the hardware. The physical address, on the other hand, is what the memory unit actually sees. It is the tangible, real-world location inside the RAM. This is a classic comparison that repeatedly yields 5 to 6 easy marks. Don't leave them on the table. To anchor that theory into practice, let's talk about segment tables. An exam question will typically ask you to translate a logical address to a physical address using one of these tables. How do you actually do it? Well, you take the segment number they give you, find its corresponding base address on the table, and then simply add the offset to that base. Super easy, right? The only trick you have to watch out for is making sure your offset doesn't exceed the length limit. If it does, boom, that's a segment fault. But once you know the rule, it's remarkably straightforward. Now, the absolute crucial point of Unit 4 is page replacement. Calculating page faults for 3 specific algorithms is a guaranteed hard category question. We're talking up to 19 marks, and it appears in almost every single paper. You have got to practice tracing these 3. First in, first out, which literally just replaces the oldest page. Least recently used, or LRU, which looks backward in time to replace the longest unused page. And optimal, which is kind of cool because it looks forward in time to replace the page that won't be used for the longest period. Seriously, master these 3 and your score is going to skyrocket.
Part 4, disk scheduling and I/O. These are the guaranteed numericals.
Okay, This is Unit 5's absolute crown jewel. Our data proves that disk scheduling numericals will appear in literally every single exam paper without fail. To solve these guaranteed 19-mark questions, you just need to internalize 4 core movement rules for the disk head. FCFS is super easy. Just execute them in the exact order given. SSTF, or shortest seek time first, means wherever the head currently is, just pick the absolute closest requested track next. Then there's scan, which is basically the elevator algorithm. Move in one direction all the way to the end of the disk and then reverse. Finally, C-scan, or circular scan, moves to the end but then jumps all the way back to the start without serving any requests on that return trip. Get these behaviors down and those 19 marks are yours for sure.
All right, Part 5, Mastering System Software. We're diving into the heavy theory from Unit 6.
Think of Unit 6 as your absolute best opportunity to farm some highly repetitive, medium-level theory marks. You can literally give your calculator a rest for a minute. This is all about targeted memorization. The most frequent easy question here, asked 6 separate times actually, is an extremely straightforward distinction. System software interacts directly with the hardware and runs in the background. Think of the OS itself or compilers. It's independent. Application software, though, performs specific user tasks and runs in the foreground, like Word or Excel. And it completely depends on system software to actually function. Get that down and you've got an easy 7 to 10 marks.
Then we hit the compiler phases. Honestly, I strongly advise you to memorize the exact order of these 6 phases right now. It goes lexical, syntax, semantic, intermediate code, optimization, and finally, generation. This specific sequence, especially if you draw a simple block diagram connecting them, is asked constantly. It is an incredibly reliable way to scoop up 9 marks just for remembering a 6-step list. You really can't beat that.
Okay, Part 6, your 55-plus scoring playbook. Let's talk execution strategy. We've extracted all the highest yield topics. Now, let's bring it all together into a clear, chronological mission plan. Step 1. Sit down and perfect the Unit 4 page fault and Unit 5 disk scheduling numericals. They are absolutely guaranteed to appear and will secure you roughly 24 marks right out of the gate. Step 2. Memorize that highly repetitive Unit 6 theory we just talked about, compiler phases and loader types. Step 3. Learn the pseudocode for standard Unit 3 concurrency problems, like the producer-consumer problem. And Step 4. Pick off those easy definitions, like mutex, logical address, and system software. If you follow this exact flow, you'll efficiently secure about 65 marks of high-frequency material. I really want you to let this quote sink in. You do not need to study everything. You only need to master the highest frequency topics to secure 55-plus marks. The data proves it, because the exam features internal choices where you can usually attempt question 1 or question 2. Strategic, focused learning easily beats blind, panic-induced memorization of the entire textbook. You've got the tactical advantage now.
So you have the hidden math, you have the high-yield topics, and you have the step-by-step playbook. That massive, overwhelming syllabus has just been reduced to a highly targeted checklist. So here's my final question for you. Now that you know the hidden math of this exam, what other complex systems in your life could you conquer just by uncovering the underlying data? Get to work on this battle plan and go get those marks.